Okay, let's do another example here. This one a little different than the previous one, and starting with 192.168.6.32 this time. Notice it's not .0 in the last octet. We'll start with .32 in the last octet, and the subnet mask is 255.255.255.224. And in this case, we need again you're going to solve the problem the same way you always have before. And in this case, the question is going to be, what are the network addresses and host addresses of all systems in this diagram. That's what we want to find today. And what we put on what interface is a little bit arbitrary, but let's just say that our first network is going to be the serial link, and the second network will be the Ethernet link. The Ethernet interface of the router FA0 here will get network 2, and the serial link, serial 0 and 0 of these two routers, will get the first network. And we'll make this router get the first usable address on the first subnet, and this router will get the second usable address on that subnetwork. This router, FA0, will be the first usable address on the second network. Now, this time we didn't start off with 0 in the fourth octet. We're starting off with 32. So how many bits do we have to borrow for subnetting? And we simply have to, all we need to do is take the last octet, and let's examine it over here. Let's look at .32, and let's do it on our number line. That's what 32 is in binary. Now if we look at the subnet mask, we need to put 1s to add up to 224, which would be this. The 1s tell us what is network, and the 0s tell us what is host. So the network portion of 192.168.6.32, the network portion in the last octet, is this area, because these 1s tell us those are network bits. The 0s in the subnet mask tell us that these are host bits. So that tells us how many bits we have to manipulate to build a subnetwork. And in this case, we have 5 subnetworks to build, or 5 bits to build a subnetwork. These 5 here. Okay. So based on that, let's proceed over to, let's answer some of the questions we normally have. How many networks do I need? In this case, it's 1 and 2. How many bits will I borrow? We have 5 bits to manipulate. We can't manipulate the other 3 bits here because they were already defined by the problem that was given to us. These have already been defined. 32 means we've already had, and 32 and 224 here mean we've already had the first 3 bits defined for us as a given. So we only have 5 bits to manipulate. So if I have 5 bits to manipulate and I need 2 networks, how many bits do I need to borrow? Well, again, 2 to the n minus 2, and you can use your little table, or you can do the math. For instance, 2 to the n minus 2. Let's say I pick 2 bits. Will 2 bits be enough? 2 to the 2 minus 2. 4 minus 2 equals 2. Does that cover my network requirements? Yes, I need 2 networks, so that will work. So we will borrow 2 bits. We're going to take 2 of the bits, and that leaves us how many bits for hosts? That leaves us 3 bits for hosts. How many hosts will that support? 2 to the 3rd minus 2. 2 to the 3rd is 8, minus 2 is 6. We need 5 hosts on this network, and we need 2 hosts on this network. I'm sorry, we need 5 hosts on that network, and we need 2 hosts on this network. So does that fulfill the requirements? Yes, because each network could support 5 hosts, and 6 hosts, and the biggest requirement we have is for 5 hosts. So that'll support our design. So let's move on towards solving the problem. All right, let's start again with the network address. I believe it was 6.32. And that was the initial subnet mask, which tells us the first 3 bits were network bits. So let's blow up the last octet in binary. And we know that this portion is kind of off limits to us. Anything from here to here has been defined already by the subnet mask of 224. So we only have 5 bits to manipulate here. Now we've already said we're going to borrow 2 bits, so the next 2 bits we'll go ahead and mark those off. And the first network is 0, 0, just like it says here. That would be the first network, but we've already said, hey, that's not usable, right? 0 networks are not usable, at least at this time. I say that because later we're going to show you how they can be used. I hope that doesn't confuse you. But for now, we say they're unusable. And that later, when I mean later, that won't come until much later in your network training. No, not this semester. 0, 1 will be the first network. We set the host bits to 0, and that ends up being 192.168.6. Well, what is that? Let's see, let's get our number line out here. (32) plus 8. Remember, this is going to be the same all the way through. That's 001. 32 plus 8 is 40. Our first network address is 40. And our first host address on that network is .41. And our second host address on that network would be 010 here, is .42. So that means our serial link will use addresses 41 and 42. So let's go put that there. So that would be .41, and this one would be .42 based on our previous decisions. 192.168.6.41, 192.168.6.42. Now let's go to the next page, and let's figure out the second network. Again, this 001 is the same because that was defined for us as an entry. This is called a partial octet problem. That'll be the next network address. Notice there was more host addresses here, but I didn't solve for them because we only needed 2 for the serial link. So I jumped over to the next network address, which would be 10 here, incrementing this. Now all this from here over was the main network address. Network address. These 2 bits are for subnetting, and these bits are for hosts right now. Hope that makes sense to you. So this network address is 192.168.6.48. 32 plus 16 is 48. That makes sense because we're incrementing on the 8 position. So we have 8 difference between the two networks. The first host would be 001.49. Second host would be 010, which would be .50. The third host 011, which would be .51. Then 100, which would be .52. And this is going to be the same, and this is going to be the same all the way down. And notice, let's add up 52 here. 32 plus 16 is 48, plus 4 is 52, so we know we're doing our math right. The next host would be 101, which would be .53. The following host would have been 110, which would be equal to .54, and that would be the last host that was usable, because 111 would be .55, and that would be the broadcast, with .56 being the next network address. So the usable addresses here run from 49 through 54. So we would see the previous page. This would address on the FA0 would be .49, and our host would occupy .50 through .54, the broadcast address being .55. Okay, work through this one if you need any help. Try that one again. I know the tricky part here is that we started out with 32 instead of 0 here. And what that means is, and the subnet mask tells us that some of the last octet has been defined already for us. So that's the difference in this problem, that these first three bits are off limits. So all we have to play with starting the problem are 5 bits instead of the typical 8 we've been doing to this point. All right, feel free to email the instructor if you have any questions about this problem.